This is the DebugBear Web Vitals tab, combining Google's CrUX data with DebugBear's own lab test results to track real user performance trends, highlight regressions, and suggest potential optimizations. Starting at the top, you'll find a real user CrUX data analysis for the core Web Vitals, LCP, CLS, and IMP. The past month is shown by default. If all core Web Vitals are passing, the success message will appear. The good CrUX score on the right is the lowest performing core Web Vitals percentage. Here we can see the page has a score of 87%, which is the LCP CrUX score. If LCP improves, then this percentage will also improve. If any metric underperforms, you'll see an alert flagging the issue. When available, CrUX URL level data is shown for the free core Web Vitals metrics, providing real user data specific to the monitored page. If URL data isn't available, perhaps due to low traffic, CrUX origin level data is displayed instead, summarizing performance across the whole domain. If both URL and origin data are available, you can switch between both data sources at the top to compare individual page performance with overall site performance. On the left, you'll find 3 toggles to help visualize the CrUX data. Chart is the default blue chart that shows daily average values based on the selected date range. Rating chart, which shows the distribution of good, needs improvement, and poor visitor experiences. The aim is to achieve 75% in the good category across core Web Vitals. And 25-week trend. This chart displays weekly averages over the past 25 weeks. CrUX data is delayed by 28 days. The tooltip will show both the date range and the actual collection period. For example, data shown for April 20th to May 17th was recorded 6 weeks earlier. This data is mostly useful if you've recently started running tests, otherwise you have the normal test history data. Beneath the CrUX metrics are the lab test metrics. No interactions are run in lab tests, so total blocking time is present here as this metric relates to IMP. In this example, we can see the LCP score for the page improved by around 2 seconds on the 25th of February. We see a big improvement in the lab test data. However, the CrUX data shows a steady improvement in the following weeks, from over 5 seconds on the 25th of February down to just over 2 seconds 1 month later. This is because CrUX data is on a 28-day rolling average. Next is the LCP analysis. Here we can see CrUX data for TTFB and FCP. TTFB scores may differ between CrUX and lab tests. Lab tests typically produce a faster TTFB due to controlled conditions. However, on mobile, this could be the opposite. Google now provides CrUX data on the LCP subparts for image elements: TTFB, load delay, load duration, and render delay. Here we can see that the load delay is much higher than the other subparts at 815 milliseconds. This can help us to analyze the request waterfall later on. You'll also see how often the LCP element is an image versus a text element. Text elements may require different optimization strategies, so it's a good idea to see this breakdown before making changes to a page. There are also additional metrics, including navigation, showing how users are arriving at the page. The navigation breakdown can help give us an idea on why the LCP score is performing well or poor. Here we can see that a quarter of visits to the page are pre-rendered, perhaps to the speculation rules API, serving content faster to the visitor. If we saw a back-forward navigation prominent here, but back-forward cache at 0%, this would mean that visitors are using the browser back or forward buttons, but the site doesn't support the back-forward cache. Fixing that will improve the LCP score for this percentage of visitors. Check the Page Prevented Back-Forward Cache Restoration Lighthouse audit to see how to fix it. Next, we have more lab test insights, including more information related to each of the core Web Vitals. The LCP element is highlighted, showing how the browser prioritizes the LCP request during load. You can also see the full request chain for the LCP element. We mentioned the high load delay highlighted earlier in the LCP image subparts. Here we can see some potential optimizations to make. The LCP initiator is a large CSS file served from a CDN, adding a delay in the request finishing. The LCP image request then begins, starting with a low priority before the browser changes the priority to high. In the request waterfall, each LCP subpart is highlighted. Here we can see how the LCP initiator is having an impact on the load delay subpart, which is indicated in green. Underneath the request waterfall, we can see how the LCP element develops during the page load. The H1 is identified as the LCP element before the image renders. Finally, the Web Vitals tab shows lab-based debug data for the cumulative layout shift and interaction to next paint metrics. Any layout shifts are highlighted. A rendering film strip is included to visually demonstrate how the page loads over time, alongside indicators showing which long tasks could impact IMP, where users interact with the page during total blocking time.